All right, our next organisms that we're going to be looking at, we're actually going to look at two kind of at the same time here. So the first one that we're going to be looking at is Necturus. And this is the classic specimen that most people have looked at in the past. It's an amphibian. It's an amphibia. Its common name is the mud puppy or the common mud puppy. And these are very similar to salamanders. They are a salamander. Okay. The second species that we're going to look at is Lithobates. Lithobates is going to be the frog species that we look at. All right. So these individuals end up in Urodela. These are in Anura. Both are in amphibia. So they're both amphibians. And Lithobates is the one that we're actually going to dissect, and we're going to look more in depth at some of the muscles and the tissues within the body. Necturus was what we used to use before because it's a much better dissection. There's a lot more to look at with Necturus, with the salamander, than there is with the frog. But unfortunately, many of these species are becoming more rare in the wild, whereas we can always go find bullfrogs and green frogs very easily. And so we continue to use Lithobates now. But I want to start with the skeletal system of Necturus because there's some things we can look at here that are pretty interesting. And it's a good transition from where we just were at with the bony fish, with Pomadases, and it'll be a good transition from there to the frog, because the frog is actually quite unique when it gets to the skeletal system. So this is the skeletal system of Necturus. Okay? And with this skeletal system, you can see that there's actually 4 different types of vertebrae, not just 2. This running along the majority of the body is the trunk vertebrae, just like we had before. But between the trunk vertebrae and the skull is, there it is, 1 cervical vertebrae. This is hard to do, I'm telling you right now, because I can't see except on my video monitor. Right here is the cervical vertebrae. And if I go all the way down these trunk vertebrae, over top of my appendicular skeleton, my pelvic girdle, I have a sacral vertebrae. And then running posterior to that would be my caudal vertebrae. So I have caudal vertebrae and I have trunk vertebrae just like before. But now between the trunk vertebrae and the caudal vertebrae is a 1 sacral vertebrae. And between the trunk vertebrae and the skull is 1 cervical vertebrae. And if we were to look at each of these vertebrae, what we would see is that they're actually very similar to what we were looking at before with the fish. This here was my caudal vertebrae. Remember, I had the hemal canal. And once again, I'm going to have a hemal canal. But one of the big differences between the fish and Necturus is I'm not going to have that hemal spine. And that makes sense, since this individual is walking on land now. You don't want to be dragging those spines along the ground. That wouldn't be good. you will still have a process towards the top here, but it's not going to be as pronounced. And this is going to be referred to as the neural process. A process is a projection, just like a spine was, but a spine is a very elongated projection. A process is not as elongated, but it's still a projection, and it's typically a place, same with the spine, where we see muscle attaching. All right? It's a place where muscle can attach. In addition, so if we go to, in blue here is my trunk vertebrae. Same thing, I have my neural process. I have my spinal cord and my dorsal hollow nerve cord. Wait, what am I doing here? That is, okay, never, sorry. Getting turned around. This was my intervertebral disc. Sorry. Here's my spinal cord running through the neural canal. Okay? One of the things we have here on my trunk vertebrae is an additional process. Remember, this is a place for muscle attachment. And these are called transverse processes, running off to each lateral side of the vertebrae. Okay? So I have neural processes that are running towards the top, my transverse processes running along the sides, and it's these transverse processes where I'm going to see ribs articulating with the vertebrae. And so if I drew a rib, the ribs are actually Y-shaped, and they look like that. And if you look back at our Necturus, you can see those ribs coming off the transverse processes. They're not long, like what we were seeing before, but you can clearly see them. Okay? You still have a centrum, you still have the neural arch, just like we've had before, the neural canal, the hemal arch. All of that's the same as what we saw with the bony fish. One of the specialized things that we see now appearing with Necturus are pre-zygopophysis and post-zygopophysis processes. So if I were to take this vertebrae and I were to turn it around, I'll draw this in brown. So I'm now looking at a lateral view here. Here's my transverse process. Here's the centrum. Up here would be the neural process. Spinal cord's running through this area. So I'm looking at the side of all of this. If I were to do this, I would notice that there's going to be a process that runs off the front, the anterior portion, and another one that runs off the posterior portion. Such that if I look at the next vertebrae, transverse process, centrum, I would see that process on this one line up with the process on the one posterior to it. So here, these are my zygopophyseal processes. And the one that comes in the very front of the vertebrae, let me specify that one with a blue dot. That's my pre-zygopophysis because it's the first one on that vertebrae. And then with an orange dot, this one and this one, those are post-zygopophyseal processes because those are towards the back. They're the posterior process on that vertebrae. So you have a pre-zygopophysis, post-zygopophysis. On the next vertebrae, you'd have a pre and then a post, and so on and so forth. And these are where each of these single vertebrae are articulating with one another. Now, the fish vertebrae were singular. They were discontinuous bony pieces that could articulate with one another, but not very well. They were very rigid. Having this type of articulation provides a way that they can slide together, and you can see way more flexibility with an amphibian than you can with something like a fish. A fish can bend side to side very easily, but they can't bend up and down very easily. Whereas an amphibian can bend side to side and up and down very easily because of these pre- and post-zygopophyseal processes. If you go to the very anterior portion of all of this, you're going to run into the cervical vertebrae. And the cervical vertebrae looks a little bit like this. It might have a little bit of a neural process. But one thing it's going to have is a small projection moving anteriorly. And that's called the odontoid process. And the odontoid process is going to be where that cervical vertebrae articulates with the skull. Now, I brought a bigger skull in here. All right, this is a black bear skull. And the reason why I brought this in is to show you the back of it. Right here, this hole is the foramen magnum. That's where the spinal cord is coming out. And in the foramen magnum, this projection is going to be inserted into, just so that it's going to provide stability with the skull, and also it's going to provide a point of articulation with the skull. If we move on to Lithobates, I'll show you Lithobates real quick. Everything's much more reduced. We don't have as many vertebrae. You see those really big flat scapula, but we're not there yet. That's going to be the appendicular skeleton. But one of the big things that you're going to see here are these large transverse processes, but no ribs running off to the side. Our Lithobates, our frog, is lacking ribs. The same thing holds true with them that we just talked about with Necturus. You're going to see transverse processes, centrum, neural arch, neural processes, neural canal, pre and post zygopophyses, just like we saw before. They're going to have one cervical vertebrae and then a series of trunk vertebrae. they're going to have a sacral vertebrae right about here. And then, if you notice, running down the center is this elongated bone. Those are the remnants of what used to be the caudal vertebrae. And instead, they are now fused together as one long bone. And that bone is called the urostyle. So notice we don't have a hemal arch because we no longer have caudal vertebrae. We only have a urostyle. And that concludes amphibians.